Okay, in this recording, we're going to be going over the worksheet, specifically the first worksheet for Unit 3. These worksheets are getting a little bit more complicated, so I'm going to try to make sure that I take the time to walk you through these to make sure that you know exactly what you're doing. So coming through here, you've got your learning objectives right here, so this is what you're going to be doing throughout the entire week, not just the first part of the week, but the whole week. So all of the learning objectives are right here. And then coming down here, we've got our definitions. We're talking about sampling, sampling distribution, convenience sampling, cluster sampling, simple random sampling, stratified random sampling, systematic random sampling. And there are a lot more different types of sampling. Just be aware of that. These are just the most common ones. The most common one is definitely convenience sampling. But we're going to be looking at all of these. So, lectures and readings, we've got the videos. I'm going to be putting up some new videos as well, like this one. And then I'm also going to be putting up a video over the Excel workbook, and I'm going to show you that as well. And so the application coming down here, define sampling and why populations are sampled. Okay, so reasons to sample. These are reasons why we sample. And the lecture goes over this, so I'm not going to go over this in too much depth right here, but you can see these are different reasons why we would sample. And then coming down here, this is when we actually start doing some of the homework. So for instance, state the best sampling strategy for each of the following scenarios. A researcher is examining ticket sales data for a concert and would like to take a sample to find the average price paid for a ticket, whether directly from the venue or a resale site like StubHub. The researcher wants each ticket to have an equal chance of being selected. So we're going to come back up here and we're going to look at these different ways to sample. So we've got convenience sampling, cluster, simple, stratified, and systematic. And looking at all of these, I'm just going to tell you, it says, okay, a sample selected so that each item or person in the population has the same chance of being included. And so that's what the answer is to the very first one. And so we're going to put simple random sampling. And then just go all the way down and, you're going to put in all your answers all the way down. And so there is one very clear answer for each one. This one right here is one of my more favorite questions, and the reason why is because it basically gives you the opportunity to look at every single different way that you could sample something, but still looking at the exact same thing. And so a college wants to know how many hours a week their students study per week on average in relation to their work. So the college samples students based on no job, part-time, and full-time. Okay, so I'm not going to give you the answers, but I'll tell you they break them up into three different groups. And they sample from within each one of those three different naturally occurring groups. Okay. From previous surveys, the university knows the average number of hours each student works. The university breaks the students up into 0, in other words, they don't work, 0 to 10, 10 to 20, 20 to 30, and above 30, and takes a sample from each group relative to the size of the group. Okay, so you've got them broken up, just like you would with a frequency distribution, with a quantitative frequency distribution, and you've got them broken up into different classes or different strata, if you will, and so each one of these groups has a certain population in these groups, and then you are able to randomly sample based on the relative amount of population. So I'll let you, the relative population in each one of those groups, I'll let you think about that as you decide which one that is. The university sends out a survey to all students and will accept whatever comes in as their sample. Okay, so that one's, once again, just pretty self-explanatory. Look through those up there and see what seems most appropriate. Okay. The university randomly samples an equal amount of students from each classification of freshman, freshman, sophomore, junior, or senior. And so, once again, just take a look at that. They're broken up into naturally occurring classes. The university orders the students based on GPA from lowest to highest. They sample every 10th student. And then last, this is not part of that question. A state wants to determine what political party affiliation is most dominant throughout the state. They randomly select 20 residents from each city. And so what is that? Okay, so coming down here, assess the context of needed data and develop the appropriate plan. So I basically want you to look at this right here and say, okay, what is the most appropriate way to sample? So a high school has constructed the following breakdown of GPA based on grade level. The school would like to take a sample of students to determine what the average GPA of the students are. Okay, so the school wants to use stratified sampling. What is a possible strata? Okay, what I mean by that is how basically looking at this, what is the strata that you're looking at? How is it stratified? How is the data broken up? And so there's only one way that you can break up this data in a way that would be considered stratified. And then how many would you sample from each strata? Okay, so list out the strata and then indicate how many you think that you would sample from each strata based on the relative frequency of observations within that strata. So the school wants to use systematic sampling after putting them in order from youngest to oldest. Choose a term for K. Now, remember this K is, in other words, every 10th, every 11th, every 12th, every 13th, whatever. So if you use every 5th, and you look at all of this right here, how many total students would you have? Okay. So it doesn't matter what K you use. I wouldn't do like 1 or 2, because that would barely be a sample. That'd almost be the population. Well, 1 would be the population. Okay, so then the school wants to cluster samples based on what's here. There is one thing in here that is naturally occurring that could be considered clusters. In other words, the students are clustered into groups already. How are they clustered into groups? And then how many do you think that you would sample from each one? Then the school wants to use simple random sampling. What's one method, or like just give me a scenario of how you could do that? Then the school wants to use convenience sampling. How could this be done? So yeah. So President Snow, this is a Hunger Games right here. President Snow would like to examine the ages of children eligible for the Hunger Games. The following data has been collected on the population. You've got the district right up here, and then you've got the amount of the family income on the left-hand side, and the number of families that meet that in the middle. So for District 12, there are 5 families that are at 70,000 or above. For District 7, you find the intersection of the two. So there are 224 families that are $40,000 to $50,000. So this is called a contingency table. So you, as you answer all of the information below, as you answer all the information in these questions below, you'll be able to use this contingency table to answer those. So for instance, Snow wants to use stratified sampling. What are possible strata? So looking at this, how could you break this up for stratified sampling? There is one clear correct answer for that. And then find the relative frequency for each strata. So after you find what strata you have broken them up into, find the relative frequency for each strata. And then if you want to sample 200 total, how many should you have for each strata? And I'll give you a hint. Multiply the relative frequency by 200 to give you the appropriate number for each sample. And for a lot of these, for this one right here, there is one clear correct answer for all of this. For this right here, not a clear correct answer, because K is subjective. Snow wants to use systematic sampling after putting every family in order based on the income. Choose a term for K. How many people would be sampled? So just look at K. So if you choose 10, 100, whatever. Yeah. Snow wants to use cluster sampling. What naturally occurring clusters already occur? Um, and once again, if they want to use 200, how would you break that up? Um, yeah. So this one right here is 200, but it's relative. This right here, this is really important, relative to the amount in each cluster already. Then this one right here is an even amount. Okay, so that's really important. Snow wants to use simple random sampling. What's one way that you could do it? Um, and then this is just, hey, if you remember Hunger Games, what are two forms of sampling that Hunger Games uses? All right, so down here, a firm wants to examine how many minutes it takes their employee to commute to work. So you've got these right here, and I'm going to give you a little bit of hint. So first of all, the firm would like to take a sample to determine how many minutes on average their employees commute to work. The firm wants to sample 30 people, use stratified sampling. What is a possible strata? Once again, what up here is stratified. The firm wants to use systematic sampling. How could you do that? Um, the firm wants to use cluster sampling. What additional piece of information could be beneficial to conduct cluster sampling? Yes, they are clustered into male and female, but you could also possibly, I don't know, cluster them based on geographical location. So 15 minutes, 15 to 30 minutes, 30 to 45, 45 to 60 minutes, that's not geographical location. That's distance, or that's time from work. When we talk about geographical location, you might want to talk about, I don't know, say like a city. And then the firm wants to use simple random sampling. What is a way that the firm could do this? And then that's going to bring you into the sampling distribution for the central limit theorem, which I'll make another video on this. But I do want to show you really quickly the Unit 3 Project Excel document. So in this Unit 3 Project Excel document, I am trying really hard to give you all one Excel document for everything. And so if you look down at the bottom, you've got the population and sample, decision tree, worksheet, sample data. Then you've got all of your individual worksheets that you're going to be doing throughout this unit. So just be aware of that. And I'm trying really hard to make it so that, like I said, it's just one stop shop for everything. So this right here, we've already been dealing with a population, we've already been dealing with population data. And so that's all that we've done so far is population data. But now we're getting into something called a sampling distribution, which is over here on the right side. So this right here is just a chart that contrasts population versus sampling distribution. So what you've already learned about the population distribution and how it relates to the sampling distribution. So if you really want to understand the difference between the two of these, I would highly suggest that you take a little bit of time and read through this and really make sure that you understand what's going on. Down here, this is a decision tree. We're not even getting into this quite yet, but this is a phenomenal resource, especially as you're going through your exam, making decisions about what to use, so on and so forth. And then it gives you all of the formulas as well. Then this right here is a worksheet that literally takes you through step by step. And it's like, okay, you do your steps with your data. It's the same exact thing. Like this right here, this decision tree and this worksheet are the exact same thing. The big difference is that it gives you a place to put your work in there and work through it a little bit by a little bit. Okay, so each one of y'all have your own data sets. So this particular workbook is for the Spotify data set. And so just to be frank, the Spotify data is literally, it's just massive. And so for every single one of you guys, I made it so that you guys only are dealing with a sample or a small part of the larger data set. And the reason why is because a lot of y'all's computers cannot handle the large data set. And so this right here only has like 230 records, where the large Spotify data set literally has, I don't even know, like close to 40,000 records, and a lot of your computers can't handle it. And so coming in right here, 3-1-1 sampling methods. So notice that notice the right here you've got the variables, okay, and then they are all. I spent a really long time cleaning all this stuff up, and some of it still isn't perfectly clean. Like for instance, there shouldn't be zeros right there, so you might need to clean it up a little bit more. But I'd rather have blanks than zeros for those. So just be aware of that. And yeah.